So today we're going to continue on in 6.4. Again, there's an animation that goes with this. So let's go ahead and go there. So remember, the other option you have in McGraw-Hill is reveal. I don't know why I have this in between page. It's really annoying. All right, so second hour, yours looks like this. We are in this module 6, lesson 4. We have looked at addition and subtraction. Today, we're going to look at multiplication. So here it is. It might be kind of loud. They were cranked up this morning. It's probably okay. All right, let's check it out.
The elimination method for solving a system of equations involves eliminating one of the variables in the system by adding or subtracting the equations. Sometimes you first need to use multiplication to create opposite coefficients. To solve this system, first multiply each term in the second equation by 3 in order to create opposite coefficients for the x terms.
So this becomes...
Next, add the equations.
Oh.
The variable x.
So this becomes negative 3x plus 12y, and it equals 30, because 3 times 10. So the first thing they did was multiply that through. Then they're moving on to step 2. That was a little quick, sorry.
X is eliminated.
So when they added these up here, the x terms eliminated. 2 plus that 12 gave them 14y. And then 12 plus 30 gives them 42.
Then solve for y by dividing each side of the equation by 14. Y is equal to 3.
3.
Now that you know the value of y, you can solve for the other variable x using either of the original equations. Using the first equation, replace y with 3.
3.
Now solve the equation. Multiply 2 by 3.
To get 6.
Subtract 6 from each side. Then simplify. Divide each side by 3. X is equal to 2.
2.
Finally, write the solution as an ordered pair. The solution of the system of equations is 2, 3.
All right. So the whole point of that, the whole reason we had to multiply first is so that we could have equal and opposite coefficients. We need opposite coefficients. All right. So they're showing this example 3 on 356. If we want our x's to be able to be canceled out, we have a positive 2, so we need a negative 2. So they're distributing a negative 2 through the entire equation. So negative 2 times x becomes negative 2x. Negative 2 times 3y becomes negative 6y. And then negative 2 times negative 5 is a positive 10. So once they have this new equation here, they're combining them. They're showing them all lined up. So our x term goes away. 5y minus 6y, Jackson, I really do need you to be quiet, becomes this negative y here. And that is equal to negative 3. So when we take the opposite of both sides, we end up y equals a positive 3. So then we put into one of the equations, it looks like they picked the bottom equation up here. They're putting a 3 in for y. Once that is simplified, 3 times 3 is 9. We're left with x plus 9 equals -5. So when we subtract 9 from both sides, x is equal to -14. So that's where they're getting this point, -14, 3. All right, so then they're just putting back into both the equations that point to show how they would check their solution. So in place of x, they're putting in a -14. In place of y, they're putting in 3. 2 times -14 is -28. 5 times 3 is 15. -28 plus 15 is -13. This does make this sentence true. Then they're checking it in the other equation, the second equation. They're putting a -14 in for x again, and a 3 in for y. 3 times 3 is 9. -14 plus 9 is -5. So it does make the second equation true as well. So since both the sentences are true, the solution of the system of equations is indeed that. We don't always check our solution, but that is a good way for you to remember how to check them. All right, so we're trying to get equal and opposite. Is there something I could multiply one of these equations by to get the opposite coefficient of the x or the y term? So looking at my y term, I would have to multiply both of them to get them to match. But if I look at my x term, how could I get this top one to be the opposite of 7x? So I'm going to multiply it by -7. So this entire equation, I'm going to distribute a -7 through here. So -7 times x, I would rewrite as -7x. -7 times 2y is -14y. And -7 times -1 is a +7. All right, so now I'm just going to rewrite the second equation as is, lining up the like terms. So 7x minus 3y equals 10. Hopefully you're not thinking too hard about this. Now we can combine them. This makes our x variable go away. We're left with -17y equals 17. So if I divide both sides by -17, y is equal to -1. If we look at our top original equation and rewrite it, x plus 2, but in place of y, we put what y equals, we then can solve for x. So simplified, this becomes x minus 2 equals -1. 2 times -1, right? So when I add 2 to both sides, x is equal to 1. So my answer to this solution would be the point 1, -1. So it's always easier when we can just multiply through one of them. But sometimes we have to multiply through both of them. So sometimes you need to multiply both equations. This is page 358. By constants in order to eliminate one of the variables. So we're trying to find common coefficients. So it looks like they're trying to get the y's to be the opposite. In order to make the top a 6y, they're multiplying everything by 3. in order to make the bottom a negative 6y, because remember, we want the opposite, they're multiplying everything by -2, bless you. Once they've done that, they have two new equations. They're adding up, that gets rid of our y term. Then they would divide both sides by 10 here. So x is equal to 4. Then they're putting 4 back into one of the original equations, looks like the top one. So 6 times 4 is 24. Then they would subtract 24. They skipped a lot of steps in this one. So once they subtracted 24, they would have 2y equals -10. So when they divide both sides by 2, y is equal to -5. All right, so the hardest part about these ones is finding a common number that we can multiply them by. Sometimes if you just multiply, if we're picking y, we can multiply the top by 3 and the bottom by 4. So we would have a -12 and a +12. Or you could choose to multiply this top by 5 and this top by 6 to have a -30 and a +30. So it's kind of like we're finding common denominators, but we're finding common coefficients that have to be the opposite of each other. So if I multiply this top through by 3 and this bottom through by 4, I should have a -12y and a +12y, so I could get rid of my y terms. So this becomes -18x. You got to be really good at distributing here. -12y equals 18. And this becomes 4 times 5x is 20x. 4 times 3 is 12. This is what we want to happen. We want opposites, so they will cancel each other out. If we weren't getting opposites, we'd have to go back and multiply by different things, right? And 4 times -4 is -16. Now I can add up these equations. So 20 minus 18x gives me 2x. We just talked about how our y variable will go away. If we bring down our equal sign, 18 minus 16 is 2. So x has to equal 1. Goodness. And then we're going to put back this 1 in for x here. So I'm going to rewrite it 5 times 1. You could choose the top equation if you prefer. This one just looked more positive to me. I don't know. So now we're going to solve for y. So I'm putting in what x equals into this equation. So I'm left with 5 plus 3y equals -4. So when I solve this two-step, I'm getting rid of my 5 by subtracting 5 from both sides. So I'm left with 3y equals -9. When I divide both sides by 3, y is equal to -3. So this is the point 1, -3. All right, so we're going to go back to our 6-4 packet, and we should be able to finish up today with the remaining. So on the first page of 6-4, remember this packet does start with 6-3. There's lots of copies if you still need another one. Starts with 6-3. 6-3 should be done. But if not, definitely go back and finish that. It will definitely help you on the quiz. 6, 4 starts here. Right away, we have to multiply by something. So I would have to multiply both of these if I was trying to get x to match it, my x coefficients to match up. But what could I multiply by the top one to get it to be the opposite of my y? That's what we're asking. How can I get this to be a 2y so that it gets canceled out by the negative 2y? I just have to multiply through by a 2, right? So that's what I'm going to do, is distribute a 2 through here. So this becomes negative 12x plus 2y equals negative 6. I'm just multiplying all the terms by 2. Now I'm going to rewrite this bottom one. 5x minus 2y equals negative 8. Once I know that one of my variable terms can be canceled out, I can start adding them up. So here I would have a negative 7x. My y's go away. Negative 6 and negative 8 make negative 14. So when I divide both sides by negative 7, x is equal to 2. Then I would throw this back in, maybe to the top one, because I see that y is by itself in the top one. Negative 6 times 2 plus y is equal to negative 3. So this becomes negative 6 times 2 is negative 12 plus y equals negative 3. Excuse me. When I add 12 to both sides, we have y is equal to 9. So the answer to this system is 2, 9. When I look at number 2, I would have to multiply both to get my x's to match up. But if I'm looking at trying to turn this y into a negative 12, I could multiply it by something, right? To get negative 12. 4 times what makes negative 12? I want it to be a negative 12. Excuse me, so I'm going to multiply it by a negative 3 here. So I'm going to rewrite this top one, negative 3x plus 12y equals 18. Then I'm going to distribute that negative 3 through the bottom. Ooh, that was... So negative 12x minus 12y equals 36 times negative 3, 108. Negative 108. Yep. Yeah, I'm just gonna check myself before I move on. 3 times 36. Hey, look at that. All right, so here, now that my y coefficients are opposites, I'm gonna start adding. I've got negative 15x is equal to, well, 108. So 18 minus 108 is negative 90. So when I divide both sides by negative 15, x is equal to 6. So then I would put 6 back into one of my equations. So maybe the top one, I don't know, -3 times 6 plus 12y is equal to 18. Make sure when we know what x equals that we're putting it in for x. So we have -18 plus 12y equals 18. When I add 18 to both sides to get rid of the constant, I have 12y equals 36. Then when I divide both sides by the coefficient of y, y is equal to 3. So this is the 0.63. All right, so this next one, I notice that we would probably have to multiply through both of them to get them to match. These are already the opposite signs though. So let's make them 15 and -15. So to make this top one 15, I would multiply it by 3. To make this -15, I would multiply it by 5. Batten down the hatches. All right, so 3 times 5x is 15x plus 15y is equal to -30. Shift my rubber band contraption again. All right, and then if I distribute a 5 through the bottom, I have 10x minus 15y equals -45. So some of these numbers do start to get kind of large, but as long as we have opposite coefficients, we can start combining them so that we're eliminating a variable. This becomes 25x is equal to -75. If we're thinking quarters, this is nice, right? When we divide both sides by 25, x is equal to -3. So I don't know, I might just throw this into the top one. 5 times -3. Go sit down, Lucas. Do some math for me. No, you don't need your Chromebook. We're not using our Chromebooks right now. So if I put a -3 into this top one, I have 5 times -3 plus 5y is equal to -10. So this would be a -15, right? Plus 5y equals -10. What happens if I get rid of my constant? I'm left with 5y equals 5. So 1y has to equal 1. So the answer to this system is the point -3, 1. So we did 2 where we only had to multiply through 1 to get them to be opposites. This one we had to multiply through both of them to get them to be opposites. Do you see how it's a little bit like finding common denominators? We're finding common multiples. What could we multiply through the bottom to get my x variable to be the, or x coefficient to be the opposite of 3? I can just multiply it by -3, right? So I would rewrite this as 3x minus 5y equals 11. And then I would distribute my -3 through there. So this would be -3x plus 12y equals a positive 24. Just double checking my work. All right, so here my x terms cancel out. 12 minus 5 is 7, so I have 7y here. This is 35. When I divide both sides by 7, y is equal to 5. It looks like this bottom one has x by itself. So I'm going to rewrite that one. X minus 4 times 5 here. That's what y equals, is equal to negative 8. So I just have to simplify. X minus 20 equals negative 8. So when I add 20 to both sides, x is equal to 12. So this is the point 12, 5. Can you turn your music off or down? All right, let's do the last couple on this page. That will leave you with 2, 4, 5, 6, 7. So that seems okay. And I notice this last one on this page is like, was it 21 that I saw was similar? Yes. So those are going to be your 2 challenges for sure today. All right, so looking at this one, I would have to multiply both of them to get them to match. But I could use a negative 12 and a positive 12 because those are multiples of 4 and 3. So if I distribute a 3 through the top and a 4 through the bottom, I should be ready to roll. So I'm multiplying every term by 3. So negative 12x, negative 24y equals 24. The bottom, we're multiplying everything by 4. 12x minus 20y equals, is that 64? So yes, some of them get large for sure. So my x variable goes away. My y coefficient is negative 44y is equal to 88. So when I divide both sides by negative 44, I'm left with y equals negative 2. So I'm going to put that in maybe for the bottom one. I know 3x minus 5 times negative 2 equals 16. So I have a 3x here. Negative 5 times negative 2 becomes a positive 10 equals 16. And then I would get rid of my constant by taking the opposite of it from both sides. 3x is equal to 6. So when I divide by the coefficient of x, x is equal to 2. So this is the point 2, negative 2. X value, y value. Pay attention to which is which. All right. These are not lined up. So we would probably want to start by rearranging. I guess to get this over to the other side, I would have to add 1/3 x to both sides. And what happens now is I just have 1/3 x plus that y is equal to negative 5. So this top equation got rewrote down here after we added 1/3 x to both sides, okay? But now these are equal, but we need them to be the opposite. So we'd have to subtract this one. So I would have 1/3 x. I'm just going to rewrite this bottom equation, well, the middle equation now, I guess, plus 5y equals -9. And then I'm going to take the opposite of the bottom. So -1/3 x, -y equals 5. So this gets rid of my x term. I'm left with 4y equals -4. We always have these really nice numbers. Y is -1. This is where it is going to get a little tricky because we have to remember how to solve equations that have fractions in them. So we're going to put this back in, maybe into this bottom equation. So 1/3 x minus 1 equals -5. So when I added 1 to both sides, I would have 1/3 x is equal to -4. Remember, to turn this fraction to 1, we have to multiply it by its reciprocal. So we're really multiplying both sides by 3. Right? This becomes 1x. This becomes -12. So this is the point, -12, -1. So I think there's another one rearranged like that you need to do a bit of finagling. Number 21, that will be the challenge. So you have 12 and 13. Hopefully the others are done on that page. 18 and 20, and then 21, 23, and 24. Oh, this one is a little bit different, but I would multiply this bottom one by 5, and I think you'll be okay. You are going to end up with, well, that one's a little tricky. I'll star that one. If you don't do it, it's all right. You're not going to have something quite as complicated to deal with for sure, but we'll look at that, hopefully. All right, so you're finishing up 6-4. Anything that hasn't been completed yet, you should know how to complete. Okay? So let me know how I can help. Don't forget, if you haven't finished the boom deck, to do that from yesterday or other boom decks.